Hello, welcome to this week's problem of the week. For this problem, we're trying to figure out how many triples A, B, and C, where A, B, and C are all positive integers. We're figuring out how many of those triples exist such that A plus AB plus ABC is equal to 11. So from the onset, we can see that each of the terms in the left-hand side of the equation contains an A. So the first thing we'll do is we'll factor an A out. So having done that, we find that A times 1 plus B plus BC is equal to 11. And 11 is a prime number. So the only factors are 1 and 11. So we can say that there are only two factors. So A can be either 1 or 11. So we'll try both of those cases out. So we find that if we plug in, if we set A equal to 1, 1 plus B plus BC is equal to 11. And if we set A equal to 11, 1 plus B plus BC is equal to 1. We can see for the case where A is 11, 1 plus B plus BC is equal to 1. And because we're adding 1 to both, because we have 1 on this side and this side, that means that B plus BC would equal 0, which is only the case if B is equal to 0. And that violates the statement that A, B, and C are positive real integers. So we can't have a case where A is equal to 11. So we'll only look at cases where A is equal to 1, because 1 plus B plus BC, there are cases where B and BC are positive integers. So now that we know that A can only equal 1, we'll look at what's inside the parentheses, namely 1 plus B plus BC being equal to 11. And so we will first, we have 1 on this side, so we'll subtract that from both sides and look at the resulting expression. So we have B plus BC being equal to 10. And as you can see on the left-hand side, each of the terms has a B in it. So once again, we'll just factor B out and then see what we can do with it. So we have now B times 1 plus C is equal to 10. So we're going to do, again, what we did up here and look at all the possible factorizations of 10. So there are 4 factors of 10, 1, 2, 5, and 10. So we'll set B equal to all of these and see if, for all those factorizations, it fits the condition set above. So what I've done is I've just set B equal to all the factors of 10, and then the alternative factors will equal 1 plus C. And you can see that for B equal to 10, we'll have 1 plus C equal to 1. And so if you subtract 1 from both sides, you'll find that C is equal to 0. And that, again, violates the condition that they all must be positive integers. But for the remaining 3, we see that the conditions are met because C will be a positive integer for all 3 of those cases. So now we'll just find what C is for each of these cases. So now we have if B is equal to 1, C is equal to 9, B is equal to 2, C is equal to 4, and if B is equal to 5, then C is equal to 1. So now we have we can't do anything more with this expression. So now all we have to do is just assemble the triples, and figure out how many there are. So as you can see, just taking the information that we assembled over here, we see that the triples we get are 119, 124, and 151. The question asks how many triples we can find. We see here that the answer is equal to three triples that satisfy the conditions above. Thank you so much for watching this week's Problem of the Week. Be sure to subscribe to our YouTube channel, follow us on Facebook and Twitter, and check out our website, centerofmath.org. Thank you.